So in this question here, we're going to try and convert this function here into a power series. Now, this function here, what we're going to try and do is to get it into the kind of format of our favourite geometric series that we use for most of these questions, 1 over 1 minus x, which can be modelled like this as a power series for the radius of convergence to be a less than 1. So therefore our interval of convergence, I'll just put IOC, that is just -1 to 1, with the endpoints obviously missed out because we've got round brackets. So let's go about setting this into this kind of format. That's the first thing we've got to try and get this into a power series. So to get the 1 on the top, I'm just going to take the 2x out and multiply it by 1 over. So we'll just go 2x times 1 over 9 minus 4x squared. So that's the first logical step is to take this numerator out, leave it like this. So next thing I want to do, I've got a 1 in my numerator which is matching, I've got the minus sign which is good, but I've got a 1 here but a 9 here. So therefore I can divide all the terms by 9. So let's try that. So then that will give me 2x times 1 over 9 times 1 minus 4/9 x squared. So that's the equivalent of what we got here. Now to get the 1 back in this, what I will do is I'll just take this 9th out, then I'll be left with a 1 and a 1, which is my goal. So now I'll have 2x over 9, so that's bringing this out to here. And then I can write this now with a 1 in my numerator, 1 in my denominator, and 4/9 x squared. So we're well on the way. Now I notice here 4 and 9 can be, they are exact square numbers, so we can take the square root of those and write them with the x and square the whole thing. So that's going to help us to try and form our power series. So let's do that. So now we've got 2x over 9 times 1 over 1 minus. Now take the square root of the top and bottom. I've now got 2/3. And then take the square root of the x squared, I've just got x. And then what I can do is I can just square the whole thing. So that is equivalent to that if I square that off. So now I've got 2x over 9 times this here. Now this here I can form into a power series already. So let's bring this up to here. So now I've got 2x over 9, just to continue. 2x over 9. And now I'm going to write this as a power series and multiply it by my 2x over 9. So I can go from n equals 0 to infinity. So 2x over 3 squared. With my x to the n, I can rewrite this now as 2x over 3. And then as it's squared, I just raise that to the 2n. Because this one here will just be x. This one here will be x squared. So it's to the 2n. So that's well on the way to forming a power series. Now this, you could submit this as your end result, it's not incorrect, but there's more we can do with this. And we've also got to invite this 2x over 9 inside the summation. So let's break things apart now. So now we've got 2x over 9, sticking with breaking this apart. So n equals 0 to infinity. Now if I take my coefficient out, 2/3, let's do that first. So then I've got 2/3 to the 2n. That just leaves me with my x on its own with the 2n. So then I've got x to the 2n. Okay, now I need to go about bringing my 2x over 9 inside now. So before I do that, I think I'm going to break this apart now into 2 separate coefficients as well. So let's do that first. So now I've got 2x over 9, n equals 0 to infinity. Now I've got 2 to the 2n, and then I've got 1/3 to the 2n. So I'm going to write these separately. You'll see why in a minute, because when I bring this 2/9 in, I'm going to need to mess around with things a little bit. And then I've got an x to the 2n. So that's all good. So now what I need to do is have a bit of space on the board, take this along up to here, and let's continue with these calculations. Okay, so now I've moved this calculation so far up to here, and let's work from here and bring the 2x over 9 inside the summation. So let's just do that. Let's see what we get. So then we've got n equals 0 to infinity. We can write 2x over 9 inside. Then we've got 2 to the 2n, 1/3 to the 2n, and x to the 2n. We could also write this as 3 to the minus 2n if we like. That would also be a valid way of doing it. So instead of writing 1/3 to the 2n, that is also the same as 3 to the minus 2n. That will be equivalent. But I'm going to leave it like this for now. Okay, so now I've got my 2x over 9 inside. Now I've gained an extra x here. So basically I can rewrite this now with this x to the 2n plus 1. So let's do that. So n equals 0 to infinity. I've taken my x out of that. Now I've got 2 to the 2n, 1/3 to the 2n, and an x to the 2n plus 1. So sometimes it's nice just to break these things apart so you can see each step. So by doing it like this, then that's how we can do that. Okay, now I've got a 2 here and a 2 here to the power of 2n. So I can take care of that, that's fine. Let me do that one step at a time. So now I can write this as n equals 0 to infinity. So just so you can see this one step at a time, I'm going to take the 2 and invite it into here, which now will leave me with 1/9. And then I've got 2 to the 2n, and then I've added another 2, so it's plus 1. Then 1/3 to the 2n, I'm going to leave that as it is for the moment, come to that in a minute. And as before, x to the 2n plus 1. Okay, now here I've got a 9 in my denominator, but here I've got a 3. But I can rewrite this, if I like, as 1 over 3 squared. So if I just change that to 1 over 3 squared, I've now got common denominators for this series here. So now 1/3 to the 2n, I could just rewrite that with 2 more 3's, 1/3 to the 2n plus 2. So let's rewrite that like that. So now I've got n equals 0 to infinity. I'm going to invite this into here. So I write 2 to the 2n plus 1. So now I'm going to take away the brackets. 1/3, I'll leave that in the brackets, to the 2n, and then plus 2, because that's a squared term. And then I've got x to the 2n plus 1. Okay, so that takes care of that. So now what I can do is, I can rewrite this as one fraction and with x to the 2n plus 1. So I'm going to rewrite this along here now. Just do this along here for the finished series. So n equals 0 to infinity. So I've got 2 to the 2n plus 1. I can divide that by 3 to the 2n plus 2. So that would take care of that. And then that's all multiplied by x to the 2n plus 1. Okay, now all I need now is to calculate my radius of convergence. Now when we broke the power series down into this format to start with, we had 2/3 x to the 2n. So therefore, for our absolute value of x to be less than 1 for here, we've here got 2/3 x. So now I can write this now. Let's write this here. Radius of convergence is 2x over 3, absolute value less than 1. So now just solve this and get x on its own. We've now got 2x absolute value is less than 3. So therefore our absolute value of x is going to be less than 3 over 2. So if I write this here, absolute value of x is less than 3 over 2. So that's my radius of convergence for this power series. Okay, now I'm going to take this off the board. I'm going to produce the first three terms of this series. Okay, let's produce the first three terms of this series. So n equals 0. Let's work out what we've got. So any 0 there, we've got just a 1. So then we've got 2 to the power of 1. Any 0 here, we're just left with 2. So then we've got 3 squared. And then any 0 here, we've got x to the 1. So x to the 1. So then that becomes 2 over 9 times x. So that's 2/9 x. So that's my first term in the series. N equals 1. Let's have a look what we got there. N is 1, we've got 3 here. So that's 2 plus 1 is 3, so that's 2 cubed. So we've got 2 cubed. Let's just put arrows just pointing so we know what we're doing. 2 cubed. Here, when n is 1, we've got 3 to the power of 4. And then here, n is 1, we've got x cubed. So then that becomes 2 cubed is 8. 3 to the 4 is 81. And then x cubed. So that's my second term. And then when n equals 2, now we can just follow this here, or we can continue with our series here. We can see what the pattern is. We now have 2 to the 5, 3 to the 6, and then x to the 5. So 2 to the power of 5 is 32. 3 to the power of 6 would just be this times 9, so that's 729. And then that would be x to the 5. And let's do an extra one. Let's do n equals 3. I like big numbers. Okay, so now we've got 2 to the 7. 3 to the 8, just adding 2 on each time. And add 2 to this, x to the 7. Okay, 2 to the power of 7, that's going to be 128. And then 3 to the power of 8 is just this one times 9. 729 times 9. Let's just work that out quickly. 729 times 9. It's got 81. So 1, carry an 8. 9 2 is 18, that's 26. 7 9 is 63, that's 65. So that's 6561. And then x to the 7. And so on. So I can just put in here, just for good measure, x to the 8. That will be our next term. Okay, so that there is my first terms of the series, and this is my representation of this as a power series with my radius of convergence in there. Absolute value of x is less than 3 over 2. Okay.